Large language models are now used across the world, in search engines, translation tools, customer service bots, even creative writing assistants. But as these models go global, one critical challenge remains. How do we know if they're truly culturally aware? We often assume that language models understand cultural nuances. After all, they've been trained on massive amounts of text from around the globe. But in reality, their performance varies wildly depending on the cultural context. A response that feels natural in Tokyo might confuse someone in Lagos, or seem offensive in Buenos Aires. This isn't just a matter of politeness, it's about fairness, safety, and reliability. When a model fails to grasp cultural specificity, it can perpetuate stereotypes, misinterpret social norms, or give inappropriate advice. And yet, until now, there's been no reliable way to measure how culturally specific a sentence is, at the sentence level. Today, I'm introducing a new framework called the Conceptual Cultural Index, or CCI, a quantitative metric that captures cultural specificity with precision, interpretability, and control. Let me walk you through how it works and why it matters. What is cultural specificity? Culture isn't a single label. It's a spectrum. Some things are universal. Turn off the lights when you leave a room. That's something most people around the world would recognize. But others are deeply rooted in place. Take off your shoes before entering a home in Japan. That's not just a custom, it's a cultural signal. Existing benchmarks treat culture like a binary. Either a fact is cultural or it's not. But in reality, cultural specificity exists on a continuum. A sentence can be partially shared, regionally common, or uniquely tied to one society. And current evaluation methods, often based on simple accuracy scores in multiple-choice questions, can't capture this nuance. They also suffer from a fundamental flaw. They don't tell us why a model failed. Was it because the model didn't know the fact? Or because it misunderstood the cultural context? We need a tool that goes beyond yes-no answers. A way to quantify cultural specificity so we can diagnose errors, improve models, and build more inclusive AI. Enter the Conceptual Cultural Index, CCI. The CCI is designed to do exactly that. It's a sentence-level metric that measures how specific a given sentence is to a target culture, not in isolation, but relative to other cultures. Here's the core idea. A sentence is culturally specific if it's much more familiar in one culture than in others. So for any sentence, say, use the purification basin at a shrine, we ask, how common is this in Japan? How common is it in Brazil? In France? In South Korea? We use a large language model to estimate, for each country, how familiar the sentence feels, on a scale from 0, not common at all, to 1, very common. Then we compute the difference between the familiarity score in the target culture, e.g. Japan, and the average familiarity across all other cultures. That difference is the CCI score. So if a sentence is widely known in Japan but rare elsewhere, the CCI will be high, close to +1. If it's equally common everywhere, the score will hover near 0. And if it's actually more common in other cultures, the score can dip down to 1. This formulation is powerful because it's relative, not absolute. It doesn't ask, is this Japanese? It asks, is this more Japanese than anything else? And unlike many scoring systems, CCI gives us interpretability. We don't just get a number, we get a full breakdown of how the sentence is perceived across cultures. That's invaluable for debugging, annotation, and model improvement. Why this works better than direct scoring? You might wonder, why not just ask the model, how culturally specific is this sentence, and get a score directly? That's what we tried, and it didn't work well. When we asked models to directly assign a cultural specificity score, the results were inconsistent. Some models gave high scores to sentences that were actually quite general. Others assigned nearly identical scores to both culture-specific and neutral sentences. Why? Because culture is a high-level abstract construct. Asking an LLM to judge it directly is like asking a human to rate the emotion of a painting, without any context. The answer becomes noisy, unstable, and hard to interpret. But CCI sidesteps this problem by breaking the task down. Instead of asking the model to understand culture, we ask it to answer a simpler, more concrete question. How familiar is this sentence in each country? This reduces cognitive load. It stabilizes the output. And it allows us to control the scope of culture by choosing which countries to include in the comparison. For example, if we're studying Japanese cultural specificity, we can use a global mode, comparing Japan to 19 G20 nations. Or use a custom mode, including only neighboring countries like South Korea and China, or excluding them entirely. This means we can fine-tune the definition of cultural specificity based on our needs, whether we're analyzing regional differences, cross-border communication, or localized AI deployment. Validating the metric, what the data shows. We tested CCI on 400 sentences, 200 that were clearly culture-specific to Japan, like, wear a yukata during summer festivals, and 200 that were general, like, drink water when you're thirsty. The results were striking. First, CCI scores showed the expected pattern. Culture-specific sentences scored much higher, often above 0.6, while general sentences clustered near 0. But more importantly, separability was dramatically better than with direct scoring. In one key experiment, we measured how well each method could distinguish between the two classes, using AUC, the gold standard in binary classification. For models like Llama 3.1 and Qwen 2.5, CCI improved AUC by over 10 points compared to direct scoring, a massive leap in discriminative power. Even more telling, the baseline model struggled with consistency. Some sentences that were clearly general received high specificity scores. Others that were deeply cultural got low marks, especially when the prompt didn't explicitly mention neighboring cultures. But CCI remained stable. And when we changed the set of comparison cultures, adding or removing neighbors, the scores shifted systematically, exactly as expected. This proves that CCI isn't just a number, it's a mechanism that reflects real cultural dynamics. A real-world use case, benchmark stratification. Now here, that's where CCI becomes truly practical. We applied it to two major Japanese common sense datasets, j-commonsense QA and j-commonsense morality. For every item in these benchmarks, we computed a CCI score, not just a label, but a continuous value from 1 to +1. Then we grouped the items into bins by CCI level, from low, general, to high, specific, and analyzed how model accuracy changed across each bin. The results were revealing. As CCI increased, meaning the sentence became more culturally specific, model performance dropped. For example, in j-commonsense QA, models like Qwen 2.5 and Llama 3.1 saw accuracy fall by up to 10 percentage points in the highest CCI bins. Even GPT-OS, one of the strongest models, showed a clear decline. But one model stood out, llm-jp 3.1, a Japanese specialized LLM. It maintained higher accuracy across all CCI levels, and its drop in high CCI bins was significantly smaller. This isn't just a statistical curiosity. It tells us something important. Models trained on Japanese data have an advantage in understanding Japanese-specific reasoning, especially in domains like social norms, etiquette, and moral judgment. And this insight would have been invisible without CCI. Because overall accuracy masks the real story. A model might score 85% on a benchmark, but if 70% of the hard questions are culture-specific, and the model fails on those, we're not getting a full picture. With CCI, we can stratify benchmarks, pinpoint weak spots, and design targeted improvements. Why this matters for the future of AI. This isn't just about measuring culture. It's about building better, fairer, and more responsible AI. Imagine you're deploying a chatbot for healthcare in rural Japan. You want it to understand local practices, like avoid visiting a shrine during menstruation, not just as facts, but as culturally sensitive norms. Or consider a global education platform. You don't want a model teaching about dinner etiquette to give advice that's inappropriate in India, where meals are often eaten with the hands. With CCI, we can annotate datasets with precise cultural specificity scores, filter training data to ensure balanced cultural representation, evaluate models not just on accuracy, but on cultural sensitivity, debug errors by asking, was this failure due to lack of knowledge or lack of cultural understanding? And because CCI is based on generality estimates across multiple cultures, it's scalable and extensible. You can apply it to any language, any region, any cultural domain. Limitations and future work. Of course, no tool is perfect. We approximated culture at the country level, but within countries, there are regional, generational, and subcultural differences that aren't captured. We also focused on Japan, so we need to test CCI across other cultures to confirm its generalizability. And like any LLM-based method, CCI inherits the biases and calibration issues of the underlying models. But that's not a flaw of CCI. It's a reminder that we need to audit not just the models, but the tools we use to evaluate them. Still, this is a major step forward. We're moving from vague assessments of cultural competence to quantitative, actionable, and interpretable evaluation. Final thoughts. The Conceptual Cultural Index isn't just a metric. It's a new lens for understanding culture in AI. It gives us a way to measure cultural specificity with precision. It allows us to control the scope of culture dynamically. It offers interpretability, not just numbers. And it enables real-world applications, from better benchmarks to more responsible deployment. As AI continues to go global, we can no longer afford to treat culture as an afterthought. We need tools that help us see, measure, and respect cultural diversity, not just in words, but in the way models think. And CCI is one of the first tools that lets us do that at the sentence level. If you're working on multilingual models, cultural benchmarks, or inclusive AI, this is a framework you should know. You can find the code, data, and full implementation details on GitHub, linked in the description. Thanks for watching. If you found this useful, please like, subscribe, and share, so we can keep pushing the frontier of responsible AI. Until next time, stay curious, stay critical, and keep asking, what does this model really understand?